It slipped past the sun, hidden behind the glare. And now it's back, dim, distant, and glowing blue. Not with a flash, not with a message, just with questions. It returns not to explain itself, but to deepen the mystery, because every time we look at 3I Atlas, we find something that doesn't quite belong. A shift in color, a nudge in its path, a chemistry that speaks a different language. We've seen Interstellar before, but this one doesn't just pass through. It interacts with light, with gravity, with the models we trust. So we gather the latest, we trace its position, we study the glow, we measure the drift, and we listen. Because whatever it is, comet, fragment, relic, it's moving, and movement in a universe this quiet always means something. Right now, it lingers in the pre-dawn hours, rising just enough to be seen through the haze if you know where to look. It doesn't call attention to itself. No cometary display, no tail sweeping the sky. Just a slow, steady arc across the morning, a quiet signature against the glow of Earth's waking horizon. The return wasn't loud, but it was precise. On October 31st, just days after its perihelion behind the sun, the Discovery Telescope in Arizona picked up the signal. 3I Atlas had emerged, still faint, still recovering from its solar encounter, but clearly there. An object that had disappeared into solar brightness was now carving its way back into view, like a message half erased, half resurrected. Since then, astronomers have followed its motion quietly. It's been climbing, morning after morning, barely lifting itself above the horizon line. The light is weak, its magnitude still too dim for casual observers, but with optics and patience, it becomes real. Each morning, it rises a little earlier, a little higher, slipping into that narrow window where skywatchers trade sleep for glimpses of something not meant to stay. It will never blaze across our sky. There will be no spectacle, no sudden streak to split the night. On December 19th, when it makes its closest pass by Earth, it'll still be over 270 million kilometers away. A distance safe, but unreachable. The kind of close that only makes sense on paper. The kind of encounter that doesn't shake the ground, but shifts something else. And yet, it matters. Because even though it's quiet, 3I Atlas is not idle. With each degree it rises, it opens a window, not just to observe it, but to ask what it's doing, how it moves, how it reacts, what it's made of. Each movement, each new arc of its path gives us another moment to listen. Right now, this is the phase of anticipation, of geometry aligning just enough for instruments to catch what our eyes cannot. A moment between silence and clarity, where drift becomes data, and where presence, even at this scale, still feels like contact. When 3I Atlas approached perihelion, its closest point to the sun, it did something we didn't expect. Its brightness surged. Instruments detected an acceleration not entirely explained by gravity. And more curiously, its light shifted blue. This wasn't just a trick of optics. Data from coronagraphs aboard solar observatories confirmed a significant spectral change, a glow richer in the wavelengths tied to molecular gases like C2 and NH2, a sign of sublimation, ice turning directly to gas under solar heat, but with intensity and timing that drew attention. The dust that once gave it a reddish hue began to fade. In its place, gas emissions dominated. Astronomers noted the absence of a prominent dust tail, which only deepened the mystery. It wasn't behaving like a typical long-period comet, but neither was it outside the realm of natural physics. Some speculated about internal heat sources. Others pointed to structural fractures, releasing gas pockets in bursts. But the most accepted explanation came down to chemistry, a volatile, rich surface layer, long dormant in interstellar cold, suddenly exposed to solar fire. And yet, the change wasn't gradual. It was sudden, reactive, almost like a decision. The timing, the luminosity, the trajectory. It all fueled old whispers, the idea that something this strange, this deliberate in appearance, couldn't simply be ice and rock. But every spectrometer, every telescope kept pointing to the same conclusion. The anomaly was real, but not unexplainable. If 3I Atlas is hiding something, it's not behind technology. It's buried in time, in origin, in the long erosion of cosmic rays shaping its surface across eons. And as the blue light fades, we're left not with answers, but with the feeling that we might finally be asking the right questions. Some even propose the acceleration could hint at non-gravitational propulsion, an idea not entirely without precedent. After all, the same speculation swirled around Oumuamua in 2017. But again, the data leaned away from fantasy. The sudden push could be modeled by jetting gas, asymmetrically released as sunlight struck volatile rich patches. No engines, no intent, just physics playing its unpredictable hand. Still, there's something poetic about the transformation. A dark, near-invisible object enters our solar system, cloaked in anonymity. It slingshots past the sun, and suddenly, light, motion, change. The way it flared blue, so briefly and so vividly, felt less like a reaction and more like a message. Not necessarily one sent, but one revealed. And just like that, 3I Atlas disappeared again, lost in solar glare, hidden by brightness, watched only by coronagraphs and distant instruments. But in those few moments of visibility, it had already complicated its own story. Not enough to unravel the mystery, but just enough to ensure it wouldn't be forgotten. To truly understand 3I Atlas, we had to go deeper. Beneath its glow, past its push, the James Webb Space Telescope, alongside NASA's Spherix mission, turned their instruments toward the object, not to chase its motion, but to analyze its makeup. What they found was strange, but not inexplicable. The chemical ratios, especially the abundance of carbon dioxide compared to water, were unlike anything typically seen in local comets. This imbalance stood out immediately, triggering new questions and reopening old ones. At first glance, these findings reignited theories of artificial design. Could 3I Atlas be synthetic? A crafted relic from elsewhere? A scout? It's the kind of chemical fingerprint that, in another context, would raise alarms or hopes. But again, the clues leaned toward nature, albeit a deeply altered one. Using laboratory simulations and high-resolution spectral data, researchers found that these strange ratios could be explained by something surprisingly mundane yet profoundly powerful: galactic cosmic rays. These particles, traveling near the speed of light, have the ability to alter molecules and sculpt chemistry across time. The hypothesis that emerged was one of cosmic erosion. 3I Atlas, wandering the vast interstellar medium for eons, has been weathered, its outer shell reshaped by an invisible storm. Simulations suggest that cosmic rays could alter the top 10 to 20 meters of the comet's crust, increasing the concentration of CO2 while suppressing water. This process, gradual but relentless, may have chemically skinned the object, creating a mask that hints at something alien while hiding something ancient. Deeper inside, the story could be very different. Untouched by radiation, sealed off from chemical evolution, the interior might remain as it was at formation, raw, pristine, and unchanged. A memory core from a planetary system long gone, not an artifact of intelligence, but of nature's first experiments. This duality, altered shell and ancient core, makes 3I Atlas far more valuable than its brightness or color alone suggest. And this is where the opportunity lies. As the comet moves farther from the sun, but closer to our instruments, it enters a window of rare clarity. Missions like JWST and telescopes like James Webb still have time to observe, to dig deeper into the spectral codes it emits. The Vera Rubin Observatory could track its motion in exquisite detail, while infrared studies could map the distribution of gases and dust more precisely. If these investigations succeed, they won't just clarify what 3I Atlas is. They could hint at what systems like ours look like in their own infancy, across the stars. In this light, 3-Eye Atlas becomes more than a traveler. It's a paradox made visible. An object altered by time, yet potentially carrying the unspoken story of somewhere else. Not alien in construction, but alien in memory. And perhaps that's more extraordinary. What 3-Eye Atlas leaves behind isn't panic or revelation, but something quieter. A kind of stillness that lingers after a question is asked but not answered. It reappeared, yes. It glowed blue. It pushed back against gravitational expectations. And with every data point, we are closer to knowing what it is. But knowing is not the same as understanding. In this narrow window, between its appearance and its departure, we're reminded that not everything strange must be unnatural. Some mysteries are made not by machines, but by time, by ice, by radiation, and solitude. The universe crafts its own riddles, and not all of them are signs. 3-Eye Atlas continues on. Its trajectory bends toward December, when it will draw closest to Earth, though not close enough to touch, not close enough to speak, but close enough to remind us that the cosmos is vast, alive, and full of things that don't quite fit the categories we've built for them. This was not the return of a ship. It was the arrival of a question. And in a world that rushes toward answers, maybe that's exactly what we needed.